Determine the behavior of the graph near the zeros of f of x equals x to the fourth plus 5x to the third minus 6x squared. First, find the zeros. We can do this by simplifying our function by taking x squared out of each of our variables to get x squared times x squared plus 5x minus 6. Further simplifying this by factoring, we get f of x equals x squared times x plus 6 times x minus 1. Giving you the zeros of 0, negative 6, and 1. Our 0 of 0 is from x squared. Our 0 of negative 6 is from x plus 6, because when x plus 6 equals 0, x equals negative 6. Same with 1. When x minus 1 equals 0, x equals 1, giving us the 0 of 1. Now that we have our zeros, we will start by finding the behavior near our 0 of 0. Near the 0 of 0, we have x squared. The power of x squared is even, so the graph bounces or touches at this point, like a parabola. Even though we know that, we still need to prove it algebraically. So, if we have f of 0 equals x squared times 0 plus 6 times 0 minus 1. We did this because we inputted 0 into our equation everywhere except where it would make it 0. So in our two variables besides our 0 variable. We simplified that to get x squared times 6 minus 1, further simplifying it to get negative 6x squared. X squared is our parabola. Negative 6 means that it is flipped, which means it opens down, giving us the behavior of our 0 of 0. Next, we have the 0 near negative 6. We have x plus 6. X plus 6 has a power of 1, because x is just an x. 1 is odd, so the graph passes through the point of negative 6. Now, we know that because x plus 6 is the equation of a line, but we need to prove this algebraically and find which way it is sloping. So we input negative 6 into our equation everywhere except for where it will equal 0. So f of negative 6 equals negative 6 squared times x plus 6 times negative 6 minus 1. To get further simplified, we end up with 36 times x plus 6 minus 7. Multiplying 36 times negative 7, we get negative 252 times x plus 6. Since we know that slope-intercept form is y minus y1 equals m times x minus x1, specifically m times x minus x1, m represents our slope. So if m is slope, then negative 252 is negative. That means we have a negative slope. Negative slope looks like that. And that gives us the behavior of our 0 of negative 6. Our final 0 is near the 0 of 1. We have x minus 1. X minus 1 has a power of 1. 1 is odd, so the graph passes through the point of 1, just like negative 6. Again, we need to prove this algebraically. So we input 1 into our equation to get f of 1 equals 1 squared times 1 plus 6 times x minus 1. Multiplied out, that is 1 times 7 is x minus 1, which can be simply written as 7 times x minus 1. Again, 7 is our slope. Slope is positive, since 7 is a positive number, so we have a positive slope. And that is the behavior near our 0 of 1.